So again, please, how many of you have been at a modular conference before? Now we change the question. So I guess those of you who have been already, you know about the YALP index, the YALP score for modular conferences. Does anyone know about this? Is this new for you? Okay, so that's weird, right? Since you've been at modular conference before. So for everyone then, the YALP score is an easy metric that allows you to say objectively how good a conference about modularity has been, or how modular a conference about modularity has been. And maybe you're guessing already. Well, I'm sad to say that for now, our YALP score is at 0. So we have to, whoever's speaking, if you're in this room, take good note of this, because we have to improve this. So if you're guessing, YALP stands for yet another Lego picture. It's really easy, but it actually works. So if you're at any talk here during the conference, and then you see a Lego picture pop up, automatically our YALP score goes up. So if you're watching, keep track of this. Make sure you tweet our score at the end. It's going to be important because then we can rank our conference among modular conferences. We can make sure we'll repeat next year. And if you're a speaker, and I see some of you here, if you don't have enough Lego pictures, you still have time, please add some. We can make this a very nice conference about modularity. So back again, thinking about modularity. So I'm probably not the best guy to just explain the benefits of modularity, right? So there are a lot of experts here that are sharing their knowledge, and no Lego pictures. That's where we were at 0 before. So yeah, to some extent and to some level, we all agree that modularity is something, it's a desirable feature, it's a desirable way to operate, to build our applications, and to work in this job we have of building source, building programs, building code. So we all know it helps with reusability, isolates code, we don't have interference with other parts of our projects. It's more manageable, we can test smaller parts, we can focus on what's our modules, our smaller ones, are actually doing and do it better than if we have to focus on the whole thing. So I'm not here to discuss why this is good, but to show what is available when we go to the front-end world. And before I do that, there's something about modularity is that everyone talks about modularity, but sometimes there are different levels or different perceptions about modularity. So I want to show you this picture. And I want to ask you, how many of you think this is a modular application project, or this is a monolithic project? So for monolithic, how many of you think this is monolithic? Modular? Okay, then sure, this is a modular project, right? It's made of many different modules, many different pieces that you can reuse. Some of them are the same, used in different places. You can put them together, you can assemble them, and then you get a bigger thing, a bigger product. But of course, in this modularity sense, you never think that, yeah, I have this car, I'll just take out the steering wheel, because maybe I don't need it, and the car should still work, right? Or maybe I'll just use 2 wheels, because why 4? There are too many. So we still see the product before as a whole. That's why some of you may think of that as a monolith, because in the end, it's not so easy to just take some of those parts out, replace them with some others. You know, it takes time, it takes effort. It's not an easy task to do. And I think Peter did a good job before. I couldn't really know, I couldn't put it into words when I was building the slides, but to me, there's a different type of modularity that comes from the Lego set. And this is what comes into, or ties into the capabilities model. So Lego just exposes a very specific interface that you can use to interconnect with other pieces. So it's not something that you get already pre-built. It's not something that stays there forever, but it just exposes a way for you to interconnect with other modules. So in a sense, everyone's just saying, okay, I'm here, this is my interface. If you want to connect with me, that's the way to do it. And a different example, so I don't show any more Lego pictures, is Mr. Potato Head. I think it's to me, this is actually the best modular piece of software or product ever. It's very simple. If you see up there, that's the actual potato head. And it's nothing more than that. It's a potato head. And what it actually has is a very clear interface. It offers some extension points, some interconnection points where you can plug in any extension you want. So it's very easy then to just create your own extensions, your own plugins, and then just play with it. And then you can, there's a very specific definition of how you can do this. And then everyone can create new components. Everyone can play with that and add to the top. And so you can get really creative with this. So, and when I say really creative, I really mean it, right? So you can do a lot of stuff. This is truly modular. And the fact that remains in the end is that at the core, deep down, deep beneath all those extra features, that's still just a potato head. Nothing changed. So I like to think about modularity also on that level, not just as pieces that you can put together and assemble while you're building your code, but also as a way to expose that modularity to the outside world. So it's not just you benefiting, but everyone else that can contribute to the ecosystem. And of course, if you've done modularity long enough, you know it's hard. So you make it wrong, things go not wrong, just unexpected. So be prepared for this to happen when you work in modular ways. So modularity is everywhere. It's in the furniture you buy from IKEA, and it's in the ways we even design or we approach design nowadays. This is a diagram of how a methodology called atomic design works. And we're using this to design, to work through our design language, our experience language. So on a design level, we're using this approach to start building the components that will, in turn, we will use in our applications. So our designers are thinking about small pieces, very abstract, very simple, reusable components. They call them atoms, and you can think of those like colors, typography, really small things, very basic, that lie in the heart of your application. Then from there, they start building bigger things. They compose different atoms, and then they get molecules. Molecules start having a different look, start having some behavior. Then if you put molecules together, you get bigger organisms. And then you can go on and go on. So this is not something that's just on software development. Most of us here are developers, but this is also something that you can apply to design. And it proves and it provides the same benefits as if you're actually building code. So now back to the part that actually we're here for today. For us, as web developers, somehow lucky for us, modularity was already built into the system in a way from the beginning. So we've always had the chance to just write code, CSS, JavaScript, in a modular way. And if you know about this, it's not really a modular way. It's just a separated way, right? But nothing prevented you from already getting some of those benefits. Like you could separate, you could compose your CSS, so you knew if there was some bug in some specific place, like your to-do list or your items, then that's the only place you had to look for it. Or if you have some libraries, you could put them together, right? That's modularity. So you also knew which part of those libraries were providing a specific set of features. But in the end, this was just throwing everything into the mix. This was our big class loader, or whatever, class path, I don't know. So we still needed something more. And this is good enough for small applications, for small websites. But as development has been growing over the past few years, this has been proven to not be enough, right? So CSS started, I guess, with some really crazy approaches. This is Max. I don't know how you spell it, but it's scalable and modular architecture for CSS. You have object-oriented CSS framework. That's a good one. You have modular CSS the SaaS way. I don't really know about that. Then you have more academic approaches like BEM methodology. And lately, we are also seeing a rise in CSS modules. In the end, and because of the constraints of the platform, these are just mechanisms, guidelines that can help you build modular CSS. It's not truly modular at this point, but if you follow one of these methodologies, either manually, like some, or as a part of your build step, like CSS modules do, then they can ensure that your CSS won't clash with other CSS, that you'll have a really isolated part of CSS that is not going to collapse or it's not going to interfere with other pieces coming into the mix. So if you're building web applications, if you're writing CSS, take a look. There are a lot of methodologies out there, and surely one of those will suit your needs, and it's going to help you a lot on how to design mostly your CSS selectors, how to design your markup in a way that you can then start putting together pieces from different places. Now, surely, if we have that in CSS, we should have one only way to do that in JavaScript, right? JavaScript has matured a lot in the past few years. It's been very fast. So you could think that by now, we would have one way to compose functionality, one way of writing modules. The sad truth is that we don't. And this is a tweet from James Burke. For those of you in the front-end world, you know him. He's the author of Require.js. It's a popular library that allows you to load modules in a specific way that we'll cover later. And what he was saying a couple of months ago, he was complaining that after 7 years that we started all this road to modularity, we still don't have a way to do it. We still don't know how to properly do it. The platform is still not ready. And why is that? It's just because modularity is hard. It's taking time for everyone to get on board. It's hard to get it right, but we're getting there. So what can you do today? Well, what you could do always was the old classic module pattern, which no one likes anymore. No one's using it. But it's always been helpful, and it's always been there. So you can this is just using the old features of the oldest feature of the language to just create a closure with which you can create a sense of encapsulation. So that variable name there, whenever you get to use this module from somewhere, it's hidden. So you don't see it from the outside world, and then you choose what to expose, like those get name, set name functions, whatever you want. So there's a way built into the system that you've always been able to use and to write modular code. The problem with this, well, this has the benefit that it's actually quite easy. It's an easy pattern. Everyone can understand when reading it, given some basic knowledge of the language. And you could write as many modules as you wanted in your files. The drawbacks, though, are that there's no way for you to know in advance what is this module exporting, what is importing. There's no way for you to statically analyze what's going on. There's no way for you to load different modules, load them asynchronously. And the fact was that everyone was doing it differently. So over the time, different patterns emerged, different libraries like YUI, jQuery, Dojo, XJS. Everyone was just shipping their own way of building modules. And this was starting to get real messy, because knowledge from one library was not interchangeable with knowledge on another one. So some effort started, and a while ago, and this is CommonJS. This is how I feel CommonJS world feels like today, because CommonJS is the module format adopted by Node.js these days with some variations. So they're pretty happy. Everyone's loving CommonJS, and CommonJS was built after the desire of getting a standardized way of building modules for JavaScript, and also to bring JavaScript to the server side. I think that's everyone's talking about today. So it works on the existing patterns, and what it does, it just creates some specific constructs like that exports. So in your Circle.js module, what you can do is just put everything you want to put out there to the outside world in the exports object. And then whatever you don't put there, when the loader down there, when someone is actually requiring your module and it's going to use it, whatever it's not inside the export object, they won't see. So there's a way that you can easily now define what you want to export. Of course, the problem with this is CommonJS is a synchronous way of loading this. There's no support natively, so whenever you're doing this, you'll either have to bundle all your code, so everything gets put together. You'll need some specific loaders for that. So Node.js is doing this. You can use Webpack or Browserify to get your code together. But you can still work, you can still write your code in a modular way. So as I said, CommonJS is synchronous in nature. And then after the desire, and this doesn't work really quite well on the browser. So in the browser, you expect some level of asynchronicity, right? And then the only option then, if you have synchronous modules, is to get everything together. So right at the beginning, AMD was spawned from CommonJS. Named this just asynchronous module loading. If you're working with Liferay, we are actually having some issues with this. That's why it's slippery. But it's pretty much the same. It has a maybe more complex syntax, but in the end, you can just say, what are my needs, what are my dependencies, and then whatever's the system that's working beneath resolves those dependencies, then they will inject those in that factory function that then you can use. This is some kind of dependency injection there, and then you can just return your object. You can say, okay, this is my module. So here we have a built-in mechanism for dependency management. It's asynchronous, so we were getting there. And then still, what we lack with here, AMD and CommonJS, is a way to be able to look at our code without running it and saying, okay, I'm missing this feature, I'm missing this dependency. There's no way this can work, or there's an error here. And because of that, ES 2015 modules were born. And this is the way to go forward, right? So everyone's actually trying to get behind this. Not everyone. Node.js community is going to have a hard time because of how this works in comparison with CommonJS, but things are working out, or discussions are being had. So the way it looks is actually very easy. If you have your module, and then you have the export naming there, so you can just say whatever you want to export to the outside world. Then from a different module, from your application, you can just import either the whole thing or specific parts. Those are named modules, so you can either get the whole as the default export or specific ones as named exports there. So you can then automatically use this functionality. The difference here is that this information is handled at the parse level. It's not, you don't actually have to run the code to know what are your module dependencies. So in a near future, you should be able to just use static analyzer tools to see if all your dependencies are met even before you have to run the code. On the dark side, there's no support for this yet. Right? So if you can build software this way, but you still have to either use loaders, transpile, or bundle your code. Reason being the loader spec is still being worked on. It's not an easy thing to do, to agree on how things should work on the browser and how they should keep working in a backwards compatible way. But I encourage you to take a look at this, start adopting it. Node.js being the biggest obstacle right now because they don't support. They're also trying to get on board and working with the TC39 board to see how this can look. So this is the way forward for the future for modules in JavaScript. And then moving one step up in the ladder, then we have HTML. So how can we give, or how can we encapsulate both pieces of functionality, markup, and styling in a way that's really reusable? And the answer for that was web components. So just in a nutshell, web components is not a technology. It's an umbrella of 4 different specifications, web specifications. It encompasses custom elements. That's what allows you to just define my element in a way that then someone else can use it. HTML imports, that would be the way of getting or receiving those components on your website, on your web application. Then you have templates, a way of inserting inert HTML in your code that can later be reused. And Shadow DOM, that's the isolation part of it, that allows you to have CSS that doesn't leak to the outside world. So in the end, you'll do something like this. You'll declare your element right up there on the top, define all its behavior. You can add your CSS. And then anywhere else in your page, you can just use it like that. And then you can rest assured that all its behavior, all its CSS is just contained within that scope of that element. So this looks really nice. It's very promising, right? The sad part is, again, support. Web components started like 2012, maybe, so it's been a long road already. We've worked a lot through this. And sadly, support has been missing for a while. But a couple of months ago or a month ago, this has actually improved. This was based on Shadow DOM. As you see, Shadow DOM version 0 and custom elements, they weren't being shipped. Both Safari and Firefox had concerns about this. But the good news is that they got together, they played around it. So now there's a new specification for both Shadow DOM, custom elements, that Safari already shipped Shadow DOM, and everyone's on board to ship the next part of the specifications. HTML imports is going to be harder, and it's being worked on, so it'll take a while. But the future is looking better and better for web components, so it's time you guys start looking at it. There are several libraries out there, like Polymer, Skate.js, that are already giving you a framework to build web components in an easy way, and then you can reuse. For now, you may use polyfills if everything's not available in your targeted browsers, but it's something already there. It's something the web is moving forward, so take a look at this. And to finish, I wanted to go through this again, get back this modularity thing to the outside world, right? So we've seen the pieces, so you can build software in a modular way. But what would happen if you wanted to, let's say, color the Germany tile in that piece of modular software? As you may guess, you will have to deconstruct everything, remove the tile, put a different tile, then construct it everything again. So sometimes modularity doesn't equate to extensibility. And that's a big part where modularity can help, providing extensible platforms that you can let others build upon. So, I don't know, ironically maybe, we found at Liferay that OSGi, the OSGi model, was actually really helpful in achieving this kind of extensibility. So this is taken from the En-ROAD docs, which I didn't read, but I just skimmed through it. And they define capability model. So they say that the capability model provides a verification tool to detect errors before deployment. But what was more important to me, what struck and what stuck to me was that you can use that to assemble components in runtime. So what does it mean? This is the diagram for metal.js, a little framework that we're building for JavaScript. As you see, it's modular again. It has several layers you can build, you can use separately. So it's not like a monolith. You don't have to use everything together. And the nice part is in the components layer. And on top of that, we have different rendering layers. So one interesting rendering layer is Google Closure templates. And with that one, what we realized is that we could build applications in a very extensible way. What this means is that you have to stop fearing mixing JavaScript and OSGi, or the front and the back end. They have to start playing together. And this is what we did. So if we have a specific module that's encapsulating all of our Metal.js framework. And on top of just providing it to the web, to our applications, it's saying, OK, I'm Metal, and I have some specific capability. I can allow you to do certain things. I'm providing you a specific set of features that you can use. So then we took the next step, right? And then we built yet another bundle, another component that was requiring this metal.js to work, these metal capabilities. And then when available, what it could do is provide yet another capability, saying, OK, maybe I can extend, maybe I can provide an image editing capability. I don't know what it looks like, but this is what I do. If someone wants it, for example, I can provide a way to crop elements. And that's how you would use metal. And then that's the part of Soy that also helps with extensibility. So you're just saying, OK, I'm here providing a way that I can crop components, and then maybe you may use it, maybe you won't. So then the final part of the puzzle is this one. So we can just get all those capabilities together, list them in a way so someone can, OK, I'm going to assemble those capabilities in a way that I can then choose which tool I'm going to use. And this is going to be easier in the video. So this is the actual product. It's shipping with Liferay DXP, and it's an image editor. So what you can do, you can just, as any other image editor, you can open an image, and then you have the regular tools. So you can, for instance, you can crop, you can resize, rotate the image. You can change the contrast, saturation, all those settings of your image. You can apply nice filters, Instagram-like. And how would you have written this a while ago? Of course, you would have modularized, but maybe you would have had to couple everything together through some really static, specific API. So what we did here, and this is the Gogo shell, so you can inspect the bundles that are in your system. And if you grab for image editor capability, you can see every one of those features are a different bundle, are a different module. Every one of those features are being provided by a very specific component. So you can do things like stopping them, 1, 2, 3 of them. And now you know that you can expect that things should still work. So for instance, I removed, I don't know which ones, filter, saturation maybe. So when I list them again, now they're not active anymore. They're still in the system, but they're not working. They're not contributing to the overall experience. What that means is that when someone goes back and tries to edit the image again, now those features are gone. So we didn't have to rebuild anything. We didn't have to rebundle. We didn't have to provide anything crazy. What's available is still working, and what's not is not even there. The system doesn't know about it. So in runtime, you can change how things work. You can provide new features. You can enhance those experiences. And again, if you stopped, of course, you can start them again. And everything should work, and new features can be added automatically on runtime without complex needs to deploy or restart. So we think if you think enough about it, there's ways which you can connect both the front end and the back end worlds in very unexpected and very useful ways for both you and your clients. So don't be afraid of jumping out of your comfort zone. If you're a front-end developer, back-end is also going to help you build really nice, really extensible and modular experiences. Thank you. So we have like 3 minutes for some questions. Anyone? I think it's about...
What is the Yelp score now?
I think it's about 7, 8. But we need help, guys, so keep pushing.
Yeah, my question is, would you recommend to step to the new ECMA script, or would you be more comfortable just to stay to the normal JavaScript right now? I mean, for a real project.
Right now, I would recommend stepping up. It's already support. I didn't show in this. I have other slides, but if you're just using ES 2015, the compatibility support on latest Safari, Chrome, Firefox, it's 100% already. So, and then if you're targeting older browsers, you always have to transpile. So there's no reason why you shouldn't. Okay. You're going to get a lot of benefits, nicer way to build your application, so go for it.
Okay, thank you.
Someone else? Okay, so wait, here, Joe.
Sorry, we only have one of these.
So you are talking about Soy and metal.js about last year, but at the moment most source code is still JSP in the Liferay portal. So is there a goal to change all this JSP stuff to metal.js?
Yeah. So this being a modular conference, I don't know if everyone's, but yeah. So our goal is to, of course, migrate all code being an UI, YUI that's deprecated. So our current plan is we're not building new stuff on top of AlloyUI and YUI anymore. So everything new is built on top of metal.js. And then we'll slowly start replacing everything we have. That's not going to happen overnight. It will take time. But the plan is to just get rid of it as soon as possible without compromising new features or the stability of the system or your ability to upgrade in the future. So we are not planning to just remove everything from day to the other. So things will stay around for a while. It's not clear 100% when will happen. So we'll inform you and we'll try to give regular updates on the state of that.